All right, Unit 1, Day 1, Function Basics and Difference Quotient. I'm thinking you're going to know most of this already, but we'll walk through it as if you don't. But we'll walk through it kind of quick. So if I'm going too quick, please ask questions. Please stop me, and we can stop and explain something or go a little deeper on something if we need to. All right, Roman numeral 1. What is a function? A function is something y equals f of x, a relation such that for every x in the domain, there exists exactly one value of y. There's a lot of ways to phrase that. Each input has only one output. If you know what you're putting in, you have to know what you're getting out. You can't put in one thing and get out two things. A lot of times people do the Coke machine model. Button 1, button 2, button 3. This will be a really simple vending machine. Coke and Sprite. If you push button 1 or 2, you get Coke. If you push button 3, you get a Sprite. Is that a function? Yeah, that is a function because you know what you're going to get. That is a function. That's a yes. If you have button 1, button 2, and button 1 goes to a Coke and a Sprite, and button 2 goes to a Sprite, is that a function? No. Because if you press button 1, you don't know what you're going to get. Or maybe you get lucky and get both, but that's not a function. That's not a functioning vending machine. So each input goes to exactly one output. Outputs can have more than one input. Inputs can only have one output. Now, graphically, that means, or the easy way to tell is the vertical line test. Every vertical line, or any vertical line, passing through the graph, passes through one and only one point. Right? You're familiar with this. So you draw a vertical line, it hits once, that's a yes. Draw any vertical line you like. So that's a function. Remember, x is input, y is output. So any value of x only has one value of y. Second picture is a little goofy looking. But any vertical line you draw, anywhere you like, only intersects once. So that's also a yes. Obviously, that third picture, you draw a line there, you got two outputs for one input. So that's not a function. So the shortcut is the vertical line test. But understand what's going on is if it fails the vertical line test, it fails because there's two y values for one x value. Right? Algebraically. So that's graphically. Algebraically, a relation is a function if you can solve for y and get one and only one equation. Now that might seem weird, like, well, how would you solve for y and get two equations? Well, let's look and find out. So let's solve this guy for y. So add 4 to both sides. Move the x squared over. Divide by 3. So I could put it all over 3, or I could make it look kind of fancy and write it like that. But that's one equation. It's some weird looking parabola because x is squared. But that's one equation. So yes, that's a function. Well, you could probably guess that the second one won't be a function, but let's figure out why it's not a function. So we're solving for y. I don't like that x in the bottom, so I'm going to multiply through by the x first to clear it out of there. So x to the fourth plus 3y to the fourth equals 25x. So let's move the x to the fourth over. divide by 3. Because we're trying to get y by itself. And then what do I do? What do I do now to get y by itself? How do I undo the fourth power? Fourth root. So let's fourth root each side. So y equals fourth root, then this is ugly. Negative x to the fourth over 3 plus 25 thirds x. But that's not exactly correct. Do you know what I did wrong there? It has to do with the negatives. The negative that being the square root, that's okay because maybe it gets fixed here. So you're right, you can't take the square root of a negative number or fourth root of a negative number. But we don't know that that's the case. Like depending on what's going on in here, that might be okay. Let's back up. Separate equation. If I have x squared equals 9, what's the solution to that equation? Plus or minus 3. Because if you take an even root, you got to remember the plus or minus. So a fourth root is also going to have that plus or minus on there. But now it's not one equation. Now it's two equations. So not a function. Another way to say that is if you plugged in an x value, you would get two y values. And that's not okay. So way back up here, this thing is not a function. And that's usually how it happens, is you take a square root or a fourth root, don't forget to put the plus or minus on there, and then you realize, oh, that doesn't work in terms of having one equation. So not a function. Right, evaluating a function. F of x is this thing. Find f of negative 4. Well, whatever's in parentheses goes in for x on the other side. So 3 times negative 4 over 2 times negative 4 plus 3. And then clean that up a little bit. Negative 12 over negative 11 plus 3 would be negative 8 plus 3 would be negative 5. So 12/5. So if we plug in negative 4, if our input is negative 4, our output is 12/5. Right? 1/8 is going to be the same type of thing. It's just going to be uglier because it's a fraction. 3 times 1/8 over 2 times 1/8 plus 3. Let's see. What to do first on that? 3/8 over 2/8 plus 3. And I'm leaving it as 2/8 because I know what I'm going to do next is multiply 3 by 8. So I'm not going to bother reducing it to 1/4 when my next step is going to be multiply through by 8 over 8 to clear out those denominators. So in the top, the 8's cancel and I'm left with 3. In the bottom, the first term the 8's cancel and I'm left with 2. And then 3 times 8 is 24. So 3/26. Let's do one more. I'm not going to do that second fraction because it's the same process. But f of x plus h. And that might seem random, but we use f of x plus h all the time in calculus. So we need you to get used to working with at least the algebra part of f of x plus h. So it works the same way. Look at the equation, and instead of plugging in -4 or 1/8, I'm going to plug in x plus h. And I guess I'll distribute, although I don't think it's going to really do me any good. I don't think anything combines or reduces or factors or anything, so I don't know that that accomplished a whole lot, but there it is. So, you know that. Whatever's in parentheses goes in on the other side. I'm out of room, but I don't want to take the time to do -3/2. It would work the same thing as 1/8. Right, this is all old news so far, right? I think. I hope. Domain and range. Speaking of old news. Whoops, and now I realize why we should have done f of -3/2. Because f of -3/2 does not exist. I'm going to rewrite that f of x 3x or 2x plus 3. So we didn't do the problem, but do you know why f of -3/2 does not exist? What is the problem with that? Not negative. It is a denominator problem, but it makes it 0. F of -3/2 equals something over 0, and I don't really care about the something, but that's a problem. Can't divide by 0. So whatever the top was, it didn't work. So that's why we would say that f of -3/2 doesn't exist, and that means -3/2 is not in the domain. And for this particular reason, it was because we can't divide by 0. Back up, big picture. Domain of a function is the set of all values of x, right? Domain goes with x, which make f of x a real number. So basically, it's the x's that work, right? If it doesn't work, then it's not in the domain. The domain can be described explicitly, or it can be implied by the expression used to define the function. For example, if you're given the function the square root of x, like it doesn't say what the domain is, but the implied domain is everything 0 or bigger, because you can't square root a negative number, so they don't come right out and say it, but it's just sort of implied, suggested that that's the domain. And a lot of times our problems are, what is the domain? Like we give you an equation and you have to figure out what the domain is. We can write the domain and range using interval notation, inequality notation, and there's a variety of other notations that are kind of crazy and I guess have their use, but we don't usually use them. Need to know the notations. I don't know that you need to know all of the notations. You definitely need to know interval and inequality notation for sure, because those are the most common and the ones that we'll use. If you see a different kind of notation, it'll usually be in a multiple choice answer, and you'll be able to tell. It might look different, there may be some weird symbols, but you'll be able to tell with the numbers that are there which one is the right answer. Right. Graphically, to find the domain and range, we can just look at what values of x are being used. Again, domain is x values, range is y values. So I look at my picture. X is the left and right stuff. So as I look left to right, where's my first value? What's my first x value that appears as I move left to right? -3. And then as I move left to right, what's the last x value that we use? Yeah, let's say infinity. I mean, the graph kind of stops at 13, but it's pretty implied or suggested that it goes forever. So -3 to infinity. Now, I intentionally left off the parentheses bracket thing What do we think about negative 3? Parentheses or bracket? Bracket, because bracket means include or equal to. What about infinity? Do you know? It's just, by definition, parentheses always goes with infinity. My reasoning to remember that is infinity. You can't ever get there. You don't really equal infinity. You're just headed that way. So you never equal infinity. You're just headed that way. So you don't. It's parentheses, not brackets. All right, y values. So y values up and down. What's my first y value that I hit moving up the graph? 1, and I think it starts at 1, so we'll include 1. And again, it looks like it goes forever up, so we'll go 1 to infinity. So graphically, it's pretty easy. Look at the picture. What values of x are covered, left and right. What values of y are covered, up and down. Analytically, to find the domain, like if you're given an equation, is what this means. So given a graph, it's pretty easy. Given an equation, it takes a little bit of work. We have to figure out what values of x make the function a real number. It's like what works, and what values of x make it not work. Typically, it is often easier to find the values of x which make the denominator 0 and exclude them from the domain. So it's sort of the opposite problem. Like we want to know what works, but it's easier to give the answer of what doesn't work. If there's an even-powered root, find the values of x which makes the interior of the root greater than or equal to 0. It's kind of the same thing. You can't divide by 0. Here's your two rules in a nutshell. Can't divide by 0. That's one thing to look for. And then you can't even root a negative number. That's a lot of words to say. Don't divide by 0, and you can't even root a negative number. So on this first one, there's no roots to worry about, but there's a fraction. So I'm going to start by saying 4x squared minus 9 can't be 0. Can't divide by 0, not allowed. So a couple ways to solve this. You could move the 9 over, divide by 4, take the square root, or you could factor it. I'm going to factor it. Just be careful, you're probably used to saying equal 0 rather than not equal 0. So x can't be negative 3/2, and x can't be 3/2. Because those would make the bottom 0, and you can't divide by 0. So this is a really lazy but efficient way to say the domain. Just say x can't be those things. Normally we would write it in interval notation. So let's see, we're okay with negative infinity up to negative 3/2. We are excluding negative 3/2. That's the whole point here. So we want parentheses on negative 3/2. And then negative 3/2 to 3/2. Again, excluding the endpoints. That's the whole point, is we want to throw out those two 3/2 values. And then 3/2 to infinity. So that's why we say that's sort of that's the official way to write it. It's kind of the annoying way to write it. The shortcut way to write it is x can't be negative 3/2, x can't be 3/2. Now, I'm okay with either one, but on a multiple choice test, it's probably going to be an interval notation. So make sure, as you're showing your work, you probably stop there, and then you start looking at your answer choices and realize that this is the right interval notation to say the same thing. The big picture, that was can't divide by 0. Second option is you can't even root a negative number. So I'm going to say I don't really care about the sixth root part. I just need 8 minus 5x I need that to be greater than or equal to 0. Because I can even root 0 or anything positive. So let's subtract the 8 over, divide by -5. We'll see who's really paying attention, whose math brain is turned on after the summer. Flip the sign. If you remember to flip the sign when I make a big deal about it, would you remember to flip the sign if I hadn't said anything? Thank you for your honesty. Thank you. It's one of those, you know the rule when the math teacher reminds you of the rule, but would you have remembered the rule on your own? I hope so. So that would be inequality notation. That is the domain. But in interval notation, so x is less than 8/5. A number line is not necessary, but maybe it's helpful to kind of visualize what's going on here. So left to right, I want all my numbers from -infinity up to 8/5. And this time, whoops, I want to include 8/5 because of the equal sign. So close circle, square bracket. Picture not necessary, but maybe picture helpful to write the interval notation. Because when you write it like this, some people are tempted to say, oh, my interval notation is 8/5 to -infinity. You're like, no, you can't say it that way. You have to give it from left to right. All right, zeros of a function. Yes, sir.
Do we not have to check for the denominator?
Oh, yes, thank you. I was just cruising right past that. So can't divide by 0. That's also in this problem. Good catch. So that's an easy one, at least as long as you remember to look for it. X can't be 2 or -2. So now I really do need that number line. I'm glad I drew it, because now I need to put some more pieces on there. Let's see, -2 would definitely be to the left of 8/5. And that would be an open circle. I can't have -2, which means my interval that I wrote was wrong. 2 is over here. That's bigger than 8/5. That's a definite open circle. But I wasn't looking there anyway, so I'm not really worried about the 2. I'm definitely worried about the -2. So, yes, interval or number line definitely helpful here. -infinity to -2. Parentheses, because we want to exclude -2. That was the whole point. And then -2 excluded with the parentheses to 8/5, but we're okay with 8/5, so bracket. And then I don't need to say anything about this 2 because it's already not included in this interval. So some people get confused, like, well, how do I account for the 2? And I'd say it's already accounted for. You're already not allowed over there. Good catch on that one. What you don't need to worry about is the numerator. So some people go overboard. So like the 2 mistakes are, I made one of them. I only looked at one piece of it. The other mistake is to like go overboard and be like, okay, let's see what makes the numerator or something. But it doesn't matter what the numerator is. Zeros of a function, zeros or roots, are things that make it equal to 0. So find the zeros of this function means set it equal to 0. I hope that factors nicely because I don't like cubic stuff. But if I factor by grouping, this is looking good. So if I factor out of 3x squared, that leaves x minus 2. Then I can factor out a minus 2, and that leaves x minus 2. That's fun when the leftovers are the same, because now you can factor the x minus 2 out front. And that leaves 3x squared minus 2. So first one's easy, x equals 2, that's one answer. And then 3x squared minus 2 equals 0. So divide by 2, or excuse me, add the 2, divide by 3. And then square root both sides. Don't forget the plus or minus. And that's still not quite, it's not wrong. What don't we like about that?
You have a radical in the denominator.
Got a radical in the denominator. So it's not wrong, but it's not, mathematically polite. So let's multiply the top and bottom by the square root of 3. So the square root of 6 over 3. Don't forget the plus or minus. Just enough space. You guys might remember the fundamental theorem of algebra. Whatever the power is tells you how many zeros there are. The power tells you the number of zeros. So that means you can know ahead of time how many answers there are. So find the zeros on a cubic, there better be 3 answers. That gets a little tricky because sometimes you get repeated answers or imaginary answers, but total number of answers is the degree of the problem. Average rate of change. Have y'all used this term before? What's that? Slope. It's fancy talk for slope. But pre-cal and calculus we start using average rate of change instead of slope, but it means exactly the same thing. So if it's new to you, it's a new term, not a new idea, because the idea is change in y over change in x. y2 minus y1 over x2 minus x1. It's just the good old algebra 1 slope formula. We've just put a fancier name on it. So average rate of change is the same thing as slope. So find the average rate of change, i.e. slope, of this function from 1/2 to 2/4, or 1/2 to 4. So P of 1/2. Oh, they were kind enough to give us a number that works really well, right? 1/2 of 2 is 1, plus 8 is 9, square root of 9 is 3. P of 4. So let's see, 8 plus 8 is 16, square root of 16 is 4. They were kind to us here. So now I've got 2 points. I know how to do the slope. Change in y, so y2 minus y1 over x2 minus x1. Now that's kind of ugly. We don't want to leave it like that, but that's so 1 over let's see, that's 3.5 or 7/2, which still looks bad because fractions and fractions. Keep it, change it, flip it. 2/7. A little bit of algebra, some algebra tricks at the end there to get a nice answer. Average rate of change. Fancy talk for slope. All right, last thing, difference quotient. Again, heavily used in calculus. This isn't the calculus part of it, though. This is the algebra part of calculus, so we want to make sure we can handle that. The difference quotient is found by determining this thing. In calculus, we use the difference quotient in the definition of a derivative. This is part of the definition. It's not all of it. The rest of it is calculus-y kind of things. But this is the algebra part. We let h get infinitesimally small. Okay, that's the calculus part. And we're not going to do that, but that's where we're headed. So find the difference quotient for g of x equals this thing. Okay, well the difference quotient would be g of x plus h minus g of x all over h. this is a spot where some of you guys will get in trouble because you're really good at math and therefore you skip lots of steps, which is sometimes okay, but sometimes dangerous, and this will be one of those dangerous spots. So I'm going to show my work. I'm not going to try to do everything and plug it in like all at once. Like, you get in trouble doing that. Like, and some of you have done it well and done it okay up until now, and some of you will continue to do it okay. But I'm telling you, please be careful. I'm going to slow down a little bit here, and I'm going to write out what g of x plus h is. I already know g of x, h is just the letter. I'm fine with those, but I'm going to take the time to write out what g of x plus h is. Not because it's hard, but because it's annoying. It's complicated. It's not difficult, but it's a lot to just sandwich into one step all at once. Okay, so if you do like skipping steps, let's see. 3x squared plus, all right, step skippers. What should I write next? What's the middle term going to be when I FOIL x plus h and then multiply by 3? 6xh. You okay with that or not? My step skippers are okay with that. I'm not sure how comfortable you are yet, so I'll not skip that step just yet. Distribute the 4, minus 7. Now we'll distribute the 3. Again, some of you would jump straight to here, which is fine, if you can FOIL and distribute all in one step. So there's g of x plus h. It's just annoying. That's why I would take the time to write it out, rather than try to do it all in your head and then stick it in here. Okay, so all of this goes in for g of x plus h. 3x squared plus 6xh plus 3h squared. I guess I should have paused and said, let's take time to see if any terms combine, but they don't. G of x they gave to us, so minus. Make sure we subtract all of that though. Put the minus sign out front, and then write your g of x, and then all of that over h. Again, this is why I'm encouraging you to write out what g of x plus h is, because this is a giant mess. So when you have giant messes, skipping steps is not usually a good plan, because it's a good way to mess something up. All right, speaking of skipping steps, I'm not going to show the distributing the minus sign, because I don't want to have to write the whole thing over again. I'm just going to be careful to know that I'm distributing the minus sign. All right, now I do have some like terms. What happens with the 3x squareds? Those will cancel. 6xh doesn't have anybody he can partner with. 3h squared doesn't have anybody to partner with. 4x, though, it will cancel because that minus sign. So if I distribute the minus sign, I get a plus 4x and a minus 4x. 4h, nothing with that. Minus 7 plus 7 will cancel. Okay, I'm at a spot where some of you are going to skip the next step. I'm going to show it. Some of you are going to go ahead and divide everybody by h. I'm going to take the time to write what's left. And then realize everybody has an h in it in the top. So I can divide them all by h. I'm going to show one extra step that I honestly hope you don't show this step. But this really explains what we're doing. You can factor out the h and then cancel it. And so we're left with 6x plus 3h plus 4. So there's just a whole lot of steps. It's not hard. So you gotta know what the difference quotient is. Find the f of x plus h, and then just be careful from there on out. If it's a polynomial, like f of x, everything in f of x will cancel. If it's a polynomial, like you get into fractions and square roots and some weird stuff, it doesn't work, or it doesn't cancel so nicely. But for polynomials, it's always going to cancel. That was a lot, but a lot of it you already knew, I think. Questions on any of that? All right, I'm going to post the video again so that if you need it later, you can find it, or